Welcome back, Year 11, Lesson 2 of Stars and Planets topic. Please write down Lesson 2, Solar System Part 2, the title at the top, and the date. Diolch yn fawr. Last lesson, if you remember, we learnt about the scale of the solar system. Finished off by doing some of these questions. We're just going to build on that today. And look, there's the solar system. Remember that this planet here no longer is classed as a planet. Pluto is no longer part of that solar system family. And this diagram isn't drawn to scale. We divide the inner 4 planets here, we call them the rocky planets, and in between got the asteroid belt, and these are our large gaseous planets, the other side of the asteroid belt. Asteroid belt, remember, excuse me, is a collection of large rocks. And we plotted last lesson, if you remember, the 4 inner planets really close to the Sun, relatively speaking, and then the 4 outer planets much further away and much larger in radius. Now then, what are we going to do today? Well, first of all, it says locate a useful solar system generator online or use the information in the next table. It assumes that if the Sun was 100 millimeters in diameter, all planets are given in millimeters and distances to the Sun in meters. Let's have a quick look at that. So we are getting the relative sizes of the different planets if we assumed is the wrong word, if we chose a scale for the Sun to be 100 millimeters, which is 10 centimeters, and on the next page, on your booklet, the diameter of the Sun across here should be about 10 centimeters. Are we dealing with diameters or radii? Body diameter, yeah, diameter. And in a moment you're going to be labelling these different planets that have been located inside the Sun. And I've done one there at the bottom, Jupiter, the largest planet. I just picked the largest and easiest one. So if you'd used a bit of software, and I'm going to point you towards a bit of software in a moment, and yeah, you can put in this value here to see if we get these ones shown. And as well as producing the diameter for the different planets, so Mercury 0.3 of a millimeter, that is the smallest of all the planets. So the smallest of all the planets would be this one here. So you would label this one Mercury. It is tiny in comparison to the Sun. There's a little arrow here, and I'm going to click on that link in a moment. But all you'd need to put into Google would be exploratorium.edu. You can see the word in there underneath, but I think if you just Googled exploratorium.edu, it'll take you there. Not that you need to, because the information's on the book here anyway, but you might want to have a little play around for yourselves and see what different facilities the software may have. So I'll just click on here. That'll take you to the right web page. I'll put that link also into Moodle, so you'll be able to access it yourselves more easily. You could read that, but effectively you should notice that that table there is very familiar. It's the one we've just been looking at now. And interestingly, this is an American piece of software. You've included inches in there, but we're going to be working in metric, millimeters. So if I put 100 millimeters in there and then click on calculate, you can see how it works out the relative sizes of these other planets, with Jupiter being the largest, 10.2, just over a centimetre. And if we're working in other values, so if you look at the body diameter in kilometres for the Sun, you've got the actual values here for the different planets. Okay, so I'd like you then to just use this information and label the different planets on the next page, please. Press pause, and when you've labelled them all, then press play. Okay, you might have you would have noticed there was a bit of a problem there. This one here had been labelled incorrectly Mercury. You'll notice that this Pluto is there. So this piece of software must have been built when Pluto was still classed as a planet. So you don't need to know that, but then you'd have labelled the others just so. You need to know the order of the planets going from the Sun outwards to Neptune. There's a few different ways of remembering, and this seems to be one of the most popular at the moment. If you learn this mnemonic: my very excited mother just served us noodles, and you can see the first letter of the sentence is the first letter of the planet. It seems to be the most popular way of remembering. Again, when I first started teaching in the 1990s, Pluto would have been classed as a planet, and the sentence that was usually used then was my very energetic mother just swam under North Pier. So I taught that for years. Another one, and you can use whichever one you prefer, whichever one works for you. Here's one: my very easy method, just sleep until noon. I don't advocate that as a life lesson, obviously, but if the sentence helps you remember the order of the planets, well, that's fine. Now, you can do so now, or you can do it later, because one of the questions you've got later, where's it gone? Here, come up with a mnemonic to remember this planet order. So you'll be doing it there, but if you want to pause and do your own now and use it for later, that's fine. Or if you don't want to come up with your own, just use this one. My very excited. I use a different colour pen. My very excited, and so on. You can do that. Next page. Okay, so I'm just going to go through some of the concepts that we learnt in lesson 1. In particular, when we watched the Brian Cox video. How big's our solar system? It depends on what we consider to be the solar system. Well, two ways to look at this. The first way is by thinking about the particles of matter that stream away from the Sun, called the solar wind, and the particles of matter that are coming towards us from nearby stars, called the stellar wind. Our solar system could be said to end when the stellar wind becomes larger than the solar wind. And you can see that here. So the solar wind, solar always pertains to the sun, and stellar pertains to stars. A second method of deciding how big the solar system is by considering gravity. The sun's gravitational field extends a very long way into space, but there comes a point between the sun and its nearby stars where the sun's pull of gravity is less than that of a nearby star. This happens at about 125,000 astronomical units. Remember, an astronomical unit is the distance from the sun to the earth. That's over 4,000 times further away than Neptune. Now you remember Brian Cox again talking about this Oort cloud. Distance is not the scale, obviously. Now, for GCSE, we consider the solar system to certainly include these planets, and of course their moons. For example, Jupiter's got 63 moons. Incredible. Earth, of course, has got one, what we would call the moon. But let's see now what we would class as our solar system. Remember this from lesson 1? We'd include the dwarf planets and the comets that are outside the orbit of Neptune. But comets do exist way outside, and what happens to comets is they follow an elliptical path. They go around the sun and they go back round again, and their orbit time could be 70 years. And similarly, some asteroids can come in from a long way away and then go close to the sun. You might have watched some of those films. What's the one with Bruce Willis? I'll have to pause the video and find out. I often mix up Deep Impact and Armageddon was the one I was thinking about, where Bruce Willis flies off into a rocket and detonates a bomb on an incoming asteroid that's about to hit the Earth. Great film, actually. And Deep Impact. I think they're both from around about 89 or 98 actually there for Deep Impact. Turning now to page 12, you can see on the right hand side here how these comets can orbit, and this is a short period comets, those that take less than 200 years to complete an orbit around the sun, originate from the Kuiper belt. Now I'm not sure if I'm pronouncing that correctly, but you can see the belt is here. So if I can zoom in. So let's say here's a comet, it does this, and then back around, and it just goes round and round. And what the big worry is, of course, is imagine if that comet hits Earth. It could be the end of humanity. And some people think that an asteroid or a comet landing on Earth was the reason for the end of the dinosaurs, because the devastation it would have caused. And there's evidence of huge asteroid strikes in parts of the world such as Mexico, and that the fires, the dust would block out the sun for years and so on. So that's one theory there of the fall of the dinosaurs in the Jurassic period. Anyway, Danish astronomer Jan Ut, I'll get the right pen in a second. Here we go. That was too thick. Let's go down. Proposed that comets reside in a huge cloud at the outer reaches of the solar system, far beyond the orbit of Pluto. This has come to be known as the Oort cloud, after that scientist, named after the scientist. Now, you wouldn't have been born when Hayles Comet flew by the Earth in 1986. I can certainly remember that. And it was also chronicled in the Bayeux Tapestry, that's in northern France, in the Middle Ages. And it will be seen again in 2061. 2061. Oh, I'm just going to pause the video. 2 questions I got for you. Number 1, you haven't got to write these down. How old will you be when Hayles Comet passes the Earth again? When you'll be able to see it from Earth? And what is the orbital period of Hayles Comet? That's the time it takes to go once around its orbit. Just press pause and see if you can work those two out. Write it down if you want. Up to you. Okay, firstly then, how old? Well, let's say you're 16 at the moment. You're either, if you're in year 11, you're either 15 or 16. Add 40 years on, because it's 2021 at the moment. You'll be about 56 years of age. And perhaps when you're 56 years of age, you think, oh, I learned about this. In year 11 in school, in the middle of the COVID pandemic, 40 years ago. Well, I hope you do. And the second question was, what's the orbital period of the comet, Hayles Comet? Well, if you take away 1986 from 2061, that's 75 years. So, 56 years of age, and I don't think you'll be able to see 2 Hayles Comets in a year time with 56 and 75. Who knows? Who knows the way in which medicine is advancing these days. Right, what makes up our solar system? You've got an exercise to do here now underneath. And you can make notes in your booklet, but what I'd like you to do is to answer this on Study Zone. That you won't have a plenary assessment for this lesson, but what you'll have instead is a written assessment. The written assessment is answering these 8 questions here and submitting it for grading from your physics teacher. So it just says here, complete the written assignment in Study Zone under this video. Can't be completed in lesson time or for homework. Okay, so I'll make sure you do that. Extension is optional. You can see that here. Then moving on to page 13. Okay, let's think about this. I'll explain. You just think about it. We're now going to zoom out again. Think about that video you watched in lesson 1 from 1977 with that scary music, and you zoomed out from a park in Chicago. You went from looking at a picnic to the planet Earth, and then our solar system, and then our galaxy, and our cluster of galaxies. Well, it's the same here. The next scale up from our solar system is the hundreds of billions of stars that make up our spiral galaxy called the Milky Way. This diagram shows a bird's eye view, or looking from, I don't know, a bird flying out in space, but looking from millions of miles away back at the galaxy. Notice our solar system is in the suburbs of our galaxy. Now, if the galactic core is the city centre, our Earth, not our Earth, our Sun, I should say, shown here. Notice our solar is in the suburbs on a strand known as a local spur. So you can, it's local spur, not local spar, local spur. That's the path in which it's moving on. Other shops are available, of course. The galactic year is the time taken by our solar system to orbit once around the centre of the Milky Way. How many Earth years do you think this takes? Well, the answer's underneath. It takes our solar system 230 million years to do this. Look at my red pen going round and round and round. 230 million years to orbit around the core of our galaxy called the Milky Way. And if we were to zoom in, that's what this curve is showing us here. There we are, there's our sun, and the planets going around it. And all these other dots are all the other suns, not the only other suns, all the other stars. Like, our sun is just called a sun, that's the name we've given it. It's just another star. When you look up at the night sky, all the other stars you see are other suns or other stars with planets going around them. We don't know more than that really in terms of how many planets and whether there's life on those planets, because of the vastness of space. Incredible to think about. And there's billions of stars just in our galaxy. So it says here the Milky Way is a very big place. The astronomical unit which we use to compare distances within the solar system is too small. The unit we now need to use is the light year. 1 light year is defined as the distance light travels in 1 year. Again, we did this in lesson 1. So let's see if you remember 1 light year. Can you now work out the distance of 1 light year in meters? And you can write down 1 light year like that. So pause and do it now, please. Okay, what you should have written down, I worked it out by multiplying the distance light travels in 1 second by the number of seconds in a year. And the way you work out the number of seconds in a year, 365 days, 24 hours, each hour's got 60 minutes and each minute's got 60 seconds. Multiply all those together using a calculator, of course, and then you write down the answer. The answer is there then, 9.46 times 10 to the 15 meters. Now then, we're going out from the solar system to the galaxy. Now we're going to go even deeper into space. If the solar system is 250,000 astronomical units in diameter, this is equal to, I'm not going to read that out, or 4 light years. Or put it another way, light would take 4 years to travel across the solar system from one edge to the opposite edge. The Milky Way is 100,000 light years across, and the Sun is 27,000 light years from the galactic centre. Which, remember, the galactic centre is here. Our nearest star, Proxima Centauri, is 4.2 light years away. Proxima Centauri, right, is just here. So what it's saying is, from Earth, 4.2 light years to get there. So when we see it, when we're looking at that nearest star, Proxima Centauri, it's taking, what we see in is that star 4.2 years ago. So if that star were to explode, and stars do, and we'll be finding more about that soon, in lesson 3 or 4, we won't know for another 4 years, because that's how long it takes for the light to travel from there. Now you don't need to be able to work out this new unit, but for interest, it's worth knowing. When scientists describe the size of massive objects like galaxies and vast distances between them, units such as a light year become too small. As it's got here, you wouldn't quote the distance from school to your home in millimetres. You'd use miles. Well, most of you would anyway. If you live in, say, Llangefellach, or Pontley would be about 3 miles, Llangefellach must be about 5 miles, say, perhaps a bit more. You'd use those units. So another distance unit is used by astronomers. It's called the parsec, written down in short like that, which is 3.26 light years. And there's a bit more information there that you can read through at your own leisure in terms of where it came from. Quick activity for you now then. Can you put these 1, 2, 3, 4, 5, 6, 7 different distance units in ascending order, so largest at the top. So I should say descending order, so largest at the top, smallest at the bottom, largest, smallest. So it would be ascending order from bottom to top. Okay, press pause, fill in the boxes. I'll start, just in case you're not sure what to do, I'll start off, look, I'll pick the easy one, millimetres. You go for it. Okay, now you would have been able to fill it in so far. Then when you get to light minute and astronomical unit, there's not much between it. An astronomical unit is 1.49 times 10 to the 11, and a light minute is 1.8 times 10 to the 10. So you can see that this is the bigger number, astronomical unit. So that's telling us that it's taken just over a minute from light to get from the Sun to Earth. So AU, light minute. Okay, let's find out who this gentleman is. Our galaxy is part of a local group of galaxies consisting of the Milky Way, another large spiral galaxy called M31. It's not a motorway, it's a spiral galaxy, or the Andromeda galaxy. The M stands for Messier object, a series of deep space objects first catalogued by the French astronomer Charles Messier. and published in 1774. Another spiral galaxy called Triangulum M33 and a whole series of small dwarf galaxies. This map shows our local group of galaxies. It's 10 million light years across in diameter. This is about 100 times wider than our galaxy. So look, look, there's a Milky Way right in the middle. And look at all these other galaxies around us. And the story doesn't end there, of course. There are millions and billions of galaxies in the universe. We're but a drop in the ocean or a grain of sand on a beach. It's worth just reflecting on that from time to time. Our local group of galaxies is also a part of a supercluster of galaxy groups called the Virgo supercluster. The supercluster is shown below, 120 million years in diameter. There we go. Now time for you to answer some questions. And that'll be the end of the lesson then. So what I want you to do then is answer question 1 here. And these questions 1 to 5 underneath here. Okay, so pause the video, and when you've completed, press play. Right, I've done question 1 for you. You just needed to look above and pick out some of the data here in your booklet. The local group is 10 million light years. Virgo supercluster 120 million light years. Therefore, the Virgo supercluster is 12 times bigger. I'm not going to write the answers down from 1 to 5. I'll give you the verbal answers so you can check yours against it. What are the main objects in our solar system? Planets, dwarf planets, asteroids, comets, and of course the sun. What's a moon? Well, it's the object, or we call it a natural satellite, that orbits around the Earth. It takes 28 days to orbit around the Earth. Part B, the planets Jupiter and Saturn have the most moons. Now that's because they are the largest planets and therefore have a large enough gravitational field to attract those moons and keep them orbiting around them. What's meant by a galaxy? Now that's a group of stars. What's a light year? Well, that's the distance light travels in a year. How many astronomical units are there in a light year? Get the information from the booklet and divide in meters, both the number of meters in a light year by the number of meters in an astronomical unit. And why is the Andromeda galaxy called M31? Well, if you look back in your booklet, this gentleman here would be responsible for that. M, after the fact that it was the French astronomer Charles Messier who catalogued these different galaxies. And that brings us to the end of lesson 2 and the end of learning about solar systems. Next lesson we're going to look at stars and the life cycle of them. Make sure please that when you finish this video, you go back and on Study Zone you complete that written assignment. Where is it? There it is, based upon those questions. See you next time. Bye.